Let's take a look at some patterns. So we have some number patterns, we have some like picture patterns, we have like an equation for the nth term, and then you can use that equation to then just like predict or use the model to predict future values that you don't necessarily want to list them all out. So they might ask you for the nth term, right? This is an equation a to the n. It's like a function here. So let's look at this pattern. So this is 2, then 8, then 14, and then 20. You're like, what's going on there? You're like, oh, I see. The pattern is you're adding 6 every time. Add 6, add 6, add 6, and so the next term, of course, then is 26. Okay, so I can find the next term. I could find the 20th term. I could just list them all out and then just count them to the 20th term and figure out what it is. But this is why this model is going to be more helpful. This turns out to be an arithmetic sequence. So it's like a linear sequence where you're just adding 6, adding 6, adding 6, adding 6. The hard part is we want to start our first term. This corresponds to n equals to 1. So when we have writing this equation, we really have to go back to like the y-intercept. So this is kind of like y equals mx plus b. And so let's pretend I go back 1, and I would be at -4. So then it's going to be -4 plus 6n. Now think about why that worked. I want to plug in 1 and get 2. When I plug in 1 here, I get 6 times 1 plus -4 gives me the 2. And then every time afterwards, this is like the slope, right? This is like y equals mx plus b in this case. And this is the y-intercept. But this isn't the y-intercept. The y-intercept starts here. And so we really got to go back 1 to like an x equals 0 or an n equals to 0. And then you can check to make sure. And then if you want the 20th term, all you have to do is plug in 20 in here. 6 times 20 is 120. Subtract 4 is 116. Okay? All right, let's look at the next one. 7, 2, -3, -8. It sure looks like it's subtraction by 5 every time. So the next one would be -13. And the same thing, our first term, we want it to be 7. So our y-intercept, or the term before this, would actually be 12. 12 minus 5 for every n. Again, our slope here is kind of like a -5 if this was like, if you were graphing this on like on a line. But the hard part is to establish that first part. And again, just go backwards 1. The 10th term, again, just plug in 10 here. So this is going to be 12 minus 5 times 10. 12 minus 50 is going to be -38. And again, that's the beauty of the nth term or an equation, typically a to the n, that we can figure out any future term based on just plugging in. Okay, now let's do the same thing, except let's go with like a picture first. So we're going to get these boxes. And so first picture, second picture, third picture, and you know, you can keep adding more pictures, right? You could draw the next picture, it'd be this picture with 7 boxes, but numerically, it looks like this would be 1, 4, and then 9. You're like, how can I describe all of them? And if you think about that, it actually ends up being the squares. 1 squared, 2 squared, 3 squared, 4 squared, and so it is n squared. When n equals to 1, when n equals to 2, when n equals to 3, and n equals to 4, meaning the fourth figure is 4 squared boxes, 16 boxes. So if you drew the next one, this is just going to take a while. Okay, there'd be 16. Okay, there's a little tiny box in there. Okay, this next one. So we have these y's. So we have 1, and then we kind of grow there. So it's kind of 1, and then 4, and then 7, and then 10. You're like, wait a second. Every time I make this y bigger, aren't I really just adding a circle to each one of the legs? And there are 3 legs. So aren't I just getting 3 bigger every time? You're like, oh, that actually makes sense. So the next one would just have 13 little dots. So then you can think about the equation. Well, the equation is arithmetic, so it's kind of like this. So we're going to go -2 plus 3n. We got to go back to where the first one would be, and then this one is 1, and after that it's get 3 bigger and 3 bigger and 3 bigger. Okay? And then the last pattern that I like to show you is going to end up being geometric. So I started at 3, and looks like I got 3 times bigger, 3 times bigger, 3 times bigger, 3 times bigger, right? This is multiplying by 3 every time, which is much, much different than adding 3 every time. So this is geometric, and so how do you do this? Well, it looks like I can just do 3 to the n. Think about that being true. Okay, so when n equals to 1, I get 1 power of 3, and then every time I increase n by 1, I get another factor of 3. I keep multiplying by another 3. So when n equals to 1, I get 3 to the first, 3 to the second, 3 cubed, right? 3 to the fourth, and I keep growing by the cubes, or by a factor of 3, excuse me. Okay, so this gets you started on patterns. Some are linear arithmetic patterns. Here's a geometric pattern where you're multiplying. Some patterns are like based on pictures. They're going to ask you to like decide on the nth term or the function a to the n. They might ask you for like the 20th term or the 100th term. But once you have the equation, finding the 100th term is easy because you're just plugging in 100 for n. Okay, hopefully this helps you get started on patterns.